So this note paper that you picked up, it says quadratic word problems on one side. It can be folded in half. And this is what's going to be taped in on page 10 eventually when we finish. All right. So when we have quadratic word problems, most of the time, they are not going to say the words solve algebraically. When it doesn't say solve algebraically, what can you do? You can use your calculator. Use your calculator. If you prefer to solve things algebraically, go for it. When I was keying your test, I just solved everything algebraically because that's what I prefer. But of course, I know you guys don't have that love relationship I do with math. Maybe some of you do, I don't know. All right. So number one, we have 2 word problems we're going to go over, and then that other half sheet that you guys picked up, that's what your 4B-5 practice. So we didn't have a 4B-4. We skipped 4B-4 and we're headed right to 4B-5.
So this is going to be part of the practice?
So this is part of the practice, this half sheet, yes.
Okay.
All right. The main cables of a suspension bridge are ideally parabolic. Can't speak today. Parabolic. Now, what does parabolic mean? It makes a parabola, right? What type of equation is that? Oh my gosh, we're in the unit on quadratic, right? That makes sense. The cables over a bridge that is 400 feet long are attached to towers that are 100 feet tall. The lowest point of the cable is 40 feet above the bridge. So A says, find the coordinates of the vertex if the bridge represents the x-axis and the axis of symmetry is the y-axis. So that it wants this to be the y-axis and this bottom line to be the x-axis. And it wants us to find the coordinates of that vertex right here. The bottom of that cable. What type of point is that? A minimum or a maximum? Minimum. So this is our vertex. It's a min point. Where is 0, 0 on this graph? So we know 0, 0 is going to be like our origin, right? The intersection between our x and y. So where is that intersection between x and y? Yeah, the dotted line and the solid line right here. That's our 0, 0. So if that's 0, 0, what are the coordinates of our vertex? 0, 40, right? My x value doesn't change. It's still at that 0 point. It just goes up 40. So my vertex is 0, 40. Beautiful. Okay. Now it says, what is the minimum height of the cable? 40. 40. 40 feet. How do we know it's 40? Yeah, we already said that the vertex is our minimum, right? So the minimum height of the cable is 40. Then it asks, find the equation that can be used to model the cable. Okay. How can we take this picture and get an equation? What do we need to use our calculator? So right now we have 1 point. Is that enough to find an equation? What is the minimum number of points I need to find a quadratic? 3. 2 is linear, 3 is quadratic. So we got to find somewhere 2 other points on this cable. We're trying to find the equation of this, what I'm about to do, orange line here, right? That's our parabola. So what are two other points that I can have on this line?
0, 100.
0 and 100?
At 0, 100.
0 and infinity. Positive infinity.
So I think that you're trying to think of these points, right? These two edge points, because we know the height's 100.
Yeah, but like in the middle.
So let's read the equation again, the thing. It says, the main cables centrals are the cables over a bridge that is 400 feet long are attached to the towers that are 100 feet tall. So if we know that that bottom x-axis there going from the 100 to 100 is 400 feet, how far is it going from the middle to one of the edges, to one of the towers? If we know the whole thing is 400, half of it, 200 each. Now, if this is 0, 0 in the middle, and I'm going 200 to the left, what is that x value right there? Negative 200. And what is the x value over here? Positive 200. And we know the vertex is 40 feet up. So what is the y value of this point? If we know the vertex is 40 feet up,
Negative 200.
what? It's just 100. So what are the coordinates of this point?
Negative 200.
Wonderful. What are the coordinates of the right point? 200, 100. Whew! On your test, they will give you the points. You won't have to find them like this. But it's good to know how to do this type of thing. So now what can I do? If I have 3 points, where do I go? Where? Stat. Edit. I got to clear out my list. You do that by going up to the L's and pressing clear, and then going down. Go up to L1, press clear, then go down. So, how am I going to enter this?
0, negative 200, and 200.
Right, you have to make sure, it doesn't really matter what order you go in as long as it's the same order for both L1 and L2. So I'm going to do negative 200, then 0, then 200. Then on L2, I'll do 100, 40, and 100. Then what do I do? Stat. Now, do I need to store it in this case? Was it asking for solutions? Nope, it just wanted the equation, so I'm not going to bother to store it. So there is our equation. Y equals, always put y equals or f of x equals first. Y equals 0.0015 x squared. There is no b, plus 40. Any questions so far? All right. Do we want to see if you can do this, or do you want me to help you along here?
Help.
Yes. All right. I'll help you a bit here, and then with the extra time we can work on our practice. If a toy rocket is launched vertically upward from the ground with an initial velocity of 128 feet per second, then its height h after t seconds is given by the equation. Oh, so they already give you the equation. How nice of them. How long will it take for the rocket to return to the ground? How long? So it's asking at what t value will the rocket return to the ground?
We don't know the seconds.
We don't know the seconds, but what do we know?
How
The equation and what height is the ground, guys?
0.
Ah, the ground has a height of 0. So, what am I replacing in my equation to find when the height is 0?
1.
Yeah, you're replacing the y or the h of t with 0.
HFT sounds dangerous.
H of t. Okay, so there's multiple ways we can do this. Either we can do just like the other problem and use our calculator, or what is the easiest way to solve a quadratic that doesn't have a c? Nope, square root is if we, didn't someone knock? Nope, square root is when we don't have a b value. What's the easiest when we don't have a c? What do we always look to pull out first? What do we always look to pull out first when we're solving? A GCF. What is the GCF between these two?
16.
Does 16 go into both?
I have no idea.
Oh, it does?
it does.
Oh, what else though besides 16?
2, 4, 6, 8, 12. Okay, now we know
T.
Oh my gosh, you can pull a t out. You can pull a t out of both. So I'm going to pull out a negative 16t. So what is negative 16t squared divided by negative 16t? 1t. And then what is 128t divided by negative 16t?
18.
It's a
Minus 8. So, is this factored?
No, it is.
Yes, we just pulled out a GCF and boom, it's factored. How do I take factors and find solutions? If I had this, how would I then find the solutions? We're not trying to find the equation, we're trying to find the solutions. Ah, set each one equal to 0. Same thing here. I'm going to set negative 16 equal to 0 and t minus 8 equal to 0. So I divide by negative 16 to get it off of the t, and what is my first solution? 0, right? At time 0, the height is 0. That makes sense. And then what do I do to get t by itself on the second time? Add 8. So what is the other time that it returns to the ground? Which one do you think they're asking for? Yeah, it says how long will it take for the rocket to return to the ground? This is the initial time. We're looking for when it returns to the ground, which is at a time of 8 seconds. The rocket returns to the ground. Ground. Okay. After how many seconds will the rocket be 112 feet above the ground? What do we do now?
Multiply by 12, right? I mean, 12.
We wanted to know in part A when the height was 0. Now what do we want to know? When the height is 112. So instead of putting 0 in for h, what are we going to put? 112 in for h. So 112 equals negative 16t squared plus 128t. Now, if I'm trying to solve a quadratic, is this how this equation should look? No. If I'm trying to solve for t, what should I do? You have to have it be equal to 0. So I'm going to subtract 112 over. So this is 0 equals negative 16t squared plus 128t minus 112. Now, because these are crazy numbers, I think this time I am going to show you how to do this in the calculator one more time. What does 16 go into 112? No, that's not a whole number. Oh, wait, 112. Darn it, why can I not?
Yeah, 7.
All right, which would you like me to do? Would you prefer that I solve this like we've been doing algebraically or solve it in the calculator? Practice is calculator from a table. All right, let's do the calculator. What's that? So I'm going to put in negative 16. Now, what do I change that t out for? X squared plus 128x minus 112. And I'm going to look at the graph. If the graph doesn't show it nicely, which does this really show it nicely? No. Not really. Do you know what you hit?
Zoom.
Hit zoom. Then what do you hit?
Zoom out.
Go down to... Oh, why does it keep doing that? Go down to zoom fit, which is 10 or 0. And press enter.
10.
I mean, that kind of shows it really weird too. But at least you can see the parabolic shape this time. And we're trying to find the two solutions, the two x-intercepts. So what do I now hit?
Second count.
Second trace. Trying to find the 0.
Second trace.
So, oh, you really can't see it if you do zoom fit. Oh. I'm going to change the y min to be way smaller. Negative 100, I think. You go to window.
X equals.
And then the y min, you see how it went way too far down? I'm going to make the y minimum negative 100 and then take a look at it. Oh yeah, that's much better. Look at that. Now then you hit graph. Yep. So I'm going to hit second trace, trying to find the zeros. Left bound means get to the left of it. Press enter. Right bound means get to the right of it. Press enter. Guess, get right on that x-intercept. So my first solution is when t is 1.
What did you do for the?
Change the window.
Yeah.
I press window. You see it right under the screen. The second button says window.
Yeah.
And change that y min to be negative 100.
I can't find my arrow.
Then I'm going to find the second 0. So I'm going to get to the left of the second x-intercept.
So the first X.
The first x-intercept was just 1. The second one we're finding right now. So I get to the left of it, press enter. Get to the right of it, press enter, and then get right on it and press enter. And then our second time is 7 seconds. So it reaches a height of 112 at 2 places. 1 second and 7 seconds. All right. We're almost done with this problem. I know it's long. I'm so sorry. It says, how long will it take the rocket to hit its maximum height? Where on our calculator did we see the word maximum? If you hit second trace, what can you find?
Maximum.
Oh my goodness. Maximum. Number 4. Left bound. What do you think that means? Get to the left of the maximum. Now, where is the maximum? The very tippy top. So get to the left of it, press enter. Get to the right of it, press enter, and guess. Get about right on, oh gosh. And press enter. So, do you see how that X value is really, really, really close to 4? Sometimes your calculator has a very hard time getting a definitive number. If it is extremely close to a whole number, most likely it's supposed to be that whole number, but it's off by an infinitesimal amount. So you can just write, it will reach a height, its maximum height at 4 seconds. And then at what height is that maximum? What on this table, I'm sorry, oh my God, what is this called? Screen shows you the height of the maximum.
The Y.
Oh my gosh. So a height of 144. 144, what's our unit? Feet. And we're done. Whew. Any questions?
No.